Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called Operations with Rational Numbers. Go ahead and follow along as I read this out loud to you. When you multiply or divide decimals with fractions or mixed numbers, here's the advice you should follow. If the fractions would convert to repeating decimals, then you should just make everything become fractions, because repeating decimals, you can't really multiply or divide by them. Not a good option at all. So you're going to have to make them become fractions if you have any other decimals in the problem. If the fractions would convert to terminating decimals, well, then you kind of have the choice. You might still want to make everything become fractions. It kind of depends on how user-friendly the decimals would become. Like, is there only like 1 or 2 digits to the right of the decimal point, or is there like 3 or 4 or more, So you kind of have to weigh that out. It also depends on how confident you feel about multiplying and dividing decimals. Do you remember those rules from 6th grade math? So these are the things you kind of have to take into consideration. Now, you are allowed to use the page that I gave you, and hopefully this is still pink every year that I'm teaching this. If it's not pink, I apologize, but the year that I'm recording this video, it is pink, and it's the page called Common Fraction Decimal Percent Combinations that everyone should know. These are going to really help you out with a lot of the fractions that are on these guided notes and on possibly future problems as well. All right, so for example, the directions say find the value of each expression. If your answer is a fraction or a mixed number, write it in simplest form. I already did number 1 for you. Twelfths. I'm telling you right now, twelfths are going to give you some nasty repeating decimals. So will ninths. So will sevenths. Sevenths are really, really bad. Even 1/6 and 5/6 can give you some not so nice repeating decimals. And 11ths will, 13ths will, 15ths will. Since twelfths would give me a repeating decimal, I did not make this become a decimal. Instead, I made negative 4.8 become negative 4 4/5. Then I just follow the rules that I've learned from multiplying fractions and mixed numbers. Make them improper fractions first. Since the 24 and the 12 are both divisible by 12, I went ahead and reduced diagonally there. That gave me negative 2 and 1 down here. And then numerator times numerator gives me 14. Denominator times denominator gives me 5. And then I made it a mixed number 2 4/5. All right, let's see you guys try 2 problems on your own. Try number 2, try number 3. Hit pause on the video right now. Do these 2 problems, and then hit play when you're ready to see how you did. All right, did you already do number 2 and number 3? If not, you better hit pause now, because here's me going over the work. 5/8 mn. I'm going to go ahead and multiply, and since 15ths are some nasty repeating decimals, I changed 0.4 into its fraction equivalent, which is 2/5. Now, from here, I look to see where I could reduce diagonally. And it just so happens that 15 and 5 are both divisible by 5. 2 and 8 are both divisible by 2. You could also, if you're really creative, you could have reduced the 2 here by 2, and then 2 2s would make 4, reduce that 8 by 4. That's getting a little creative. Maybe some of you have no idea what I just said, so fine if that's the case. From here, you're going to take 5 divided by 5 and 15 divided by 5, and then finally you're going to take negative 2 divided by 2 and 8 divided by 2. Let's see what those results would give you. They would give you, come on, move, there. 5 divided by 5 is 1, 15 divided by 5 is 3, 8 divided by 2 is 4, and negative 2 divided by 2 is negative 1. Go ahead and multiply your numerators together. You will get negative 2. Multiply your denominators together, and you will get 60. And this can still reduce. 2 and 60 are both divisible by 2. That's going to give you negative 1/30. And I don't care where you keep the negative sign. You can put it up to the left, or you can put it up in the numerator. Either way is fine. When I'm doing my work, I like to keep it in the numerators. All right, problem number 3. W over Z. Now, this really means W divided by Z. And the W is obviously a fraction. The Z, well, you actually had the choice on this problem. You could have changed 9/16 to a decimal. However, 16ths are 4-digit decimals, not really user-friendly. So what I decided to do was to change the negative 6/10 into negative 3/5, its fraction equivalent, and then I went from there. All right, division is the same as multiplying by the reciprocal. So the reciprocal of 3/5 is 5/3. I like to keep the negative up on the numerator of my fraction so I don't forget about it. 9 and 3 are both divisible by 3. What do you get? Well, let's find out. 9 divided by 3, 3 divided by 3. That's going to give you the results of 3 and 1. 3 times -5 is -15, and 16 times 1 is 16. And there you go, -15 sixteenths. Now, if you decided to do this the decimal route, and you're curious what that answer would give you, 15 sixteenths happens to be 0.9375. And that would have been acceptable as long as you had the negative sign on the answer. All right. Now, a reminder, and I already had this on a previous packet of guided notes, but a reminder, when you add decimals, and this also applies to subtraction, forgive me for not putting that there, when you add or subtract decimals to fractions or mixed numbers, here's the advice you should follow. If the fractions would convert to terminating decimals, then just go ahead and make everything decimals, because it's a lot quicker and easier to add decimals together than it is to add fractions together, because when you add or subtract fractions, you got to have common denominators. If the fractions would convert to repeating decimals, not a good idea to try to add or subtract by, because they go on forever. So you're going to have to make everything fractions in that type of situation. All right, now that we've quickly reviewed that, would you please try number 4 on your own? Hit pause the video now, do number 4, and then hit play when you're ready to see how you did. All right, I assume you already did number 4. Let's see how you did. Now, I like to work smarter, not harder. So I noticed some of these were positives, and the original weight here of the dog was obviously also a positive. So I went ahead and added my positive numbers together first. And that's going to look like this. Now, 5 plus 5 plus 5 is 15. You'd carry the 1. 1 plus 4 is 5 plus 7 is 12 plus 1 is 13. Carry that 1. 1 plus 4 plus 2 is 7. And then the 2 here just gets dropped down. You get 27.35. That's the positives. Now, from here, I would go ahead and do the negatives separately, because when you add a negative plus a negative, you're going to add in your head. So let's go ahead and add those negatives together. I'm going to have to put some zeros here. Oh, and I should go ahead and say I am definitely making the fractions become decimals. So forgive me for not mentioning that earlier, but the 4 and 3/4 was 4.75, and the -1 and 7/8 is 1.875. -1/5 is 0.2. Now, obviously they're negatives, but when you add a negative plus a negative, you're going to still add off to the side, which is what I'm doing right now. Okay, so I did have to put some zeros here so I could line up the decimal points nicely. Obviously, the 5 in the thousands is still going to be 5,000 because you're adding into a bunch of zeros. 5 plus 7 is 12. Carry the 1. 1 plus 8 is 9. Plus 8 is 17. Plus 2 is 19. Carry that 1. 1 plus 1 plus 1 is 3. Now, this is really negative 9 or 3.925. Add that to a positive, you're now going to have to subtract their absolute values. And this is going to involve a little bit of borrowing. Now notice I had to put a 0 here to line up the decimal points. So I borrow, that 5 becomes a 4, the 0 becomes a 10, then I can subtract and get 5 and 2. I need to do some more borrowing since the 3 was smaller than the 9. The 7 would become a 6 and the 3 would become a 13. 13 minus 9 is 4, 6 minus 3 is 3, and 2 minus nothing is 2, giving me 23.425, and that is the final answer. Forgive me for not having it typed up here with the unit of measure, but that is your final answer, 23.425 pounds. All right, moving on to the next page, some reminders, and these are things that I believe I did have, mostly had on the multiplying fractions and mixed numbers guided notes and on the dividing fractions and mixed numbers guided notes, but it doesn't hurt to review. Some things to look for in possible word problems. If the problem talks about finding a fraction of something and you need to do that type of stuff in your work, That's going to be multiplying the fraction times whatever was after the word of. If it's about finding a fraction as much of something or as many of something, then that also is going to mean multiplying the fraction to whatever we're talking about. If you have a math situation that occurs multiple times, maybe it happens multiple days or multiple weeks or multiple months or multiple years, then you have to multiply by the number of days or weeks or months or years or whatever the problem was talking about. Now, problems that might need division. If you're asked to find the average of something, average, referring to the mean, would be adding up all the numbers, giving you the sum, and then dividing by however many items that you happen to have. Obviously, that's division there, so the word average would require division. If you are trying to find any kind of problem where you have to find how many items of a certain size can fit into or come from a grand total amount, how many of those items fit in that total, that is a division problem. All right, I would like for you to use the knowledge that I just reviewed with you to help you do some problems coming up. Problems 5, 6, and 7. Each of them are unique. You have to read them and understand what does the problem ask us to do, and then you're going to have to figure it out and do the work. So hit pause now, do 5 and 6 and 7, and then hit play when you're ready to see how you did. All right, I'm assuming you already did 5, 6, and 7. If not, you need to hit pause. Here we go. It said 3/5 of its previous balance. As I told you at the top of the page, if you are talking about a fraction of something and you need to find what that is, then that is going to be the fraction times the something, and that's exactly what we need to do here. Before I can find out how much more this is going to drop, I need to find out, well, what is 3/5 of the negative $7.50? So, since 3/5 was a fraction, I went ahead and changed 7.5 7.5 into 7.5. Now, 3/5 is 0.6, and I am going to show you an alternate way of doing this. For those of you who wanted to make everything become decimals, go ahead and fast forward the video to that part if you did it that way, and you'll get to see how that works. But those of you who did fractions of mixed numbers, here's what your work is going to look like. You're going to have to make this become negative 15 over 2 in proper fraction. The 15 and the 5 are both divisible by 5. That's going to give you negative 3 up here and 1 down here. Multiply your numerators together and your denominators together. That's going to give you negative 9 over 2, which is negative 4 1/2. You're not done. It changed by that much. So the question is, what is the new balance? Well, we know how much it changed by. That's going to be negative $4.50, but we got to go ahead and add that to the original balance. Now, I kept these mixed numbers. If you went ahead and made them decimals right away, that's totally fine. This is going to give you negative 11.5 or negative 11.5. But since we're talking about dollars and cents, you must write it with 2 digits to the right of the decimal point and the dollar sign on your answer. For those of you who chose to do decimals, I'm going to show you that right now. For those of you who did it the fraction way, skip past this part of the video unless you would like to see if the work would be easier as making them decimals. All right, so taking 7.5 times 0.6. Since there is 1 digit to the right of the decimal point here and 1 digit to the right of the decimal point here, tenths times tenths should give you hundredths, which will require 2 digits to the right of the decimal point. That's how it works when you multiply decimals together. Now, 5 times 6 was 30. I would have carried the 3 above the 7. Forgive me for not having this here on my work. And then 6 times 7 is 42, plus the 3 I would have carried up here gives me 45. And then 2 digits need to be to the right of the decimal point because 1 digit and 1 digit makes 2 digits on that answer. From here, same thing I was showing on the other method. This is really a negative because 7.5 times 6, since that was negative, it's negative 4.5. Now I have to add it back onto the original balance because the problem didn't just say what was the amount of change. The problem said what was the new balance at the end of the week. So I have to add the change to the new balance or to the original balance. And that's going to give me a new final balance of negative $11.50. All right, problem number 6. This is asking for the average balance of his account. To get average, you have to add the numbers in the table and then divide by how many items you have. Well, since we have 3 weeks worth of balances, we're going to divide by 3. I like to work smarter, not harder, and start by adding the positives together, because then you're going to go ahead and add off to the side. This is going to give you 5 plus 5 is 10, carry the 1. 1 plus 5 plus 8 is 14, carry the 1 there. 1 plus 2 plus 6 is 9. Bring down the 4 as well. You're going to get 49.4. But now you need to add that by the negative $20.60. A positive plus a negative, you're going to subtract off to the side. 0 minus 0 is obviously 0, but 4 is smaller than 6, so this is going to require a little bit of borrowing. The 9 will become an 8, and then the 4 becomes a 14. Subtract, you're going to get 8 here, 8 here, and 2 there, $28.80. But we're not done. That's just the sum of the 3 weeks' balances added together. We need to now divide by 3 because there were 3 items and we're trying to find the average. How many 3s fit into 28? 9 of them, because 9 times 3 is 27. Subtract, you will get 1. Bring down the 8. How many 3s go into 18? 6 of them. Now notice the decimal point is lined up. 6 times 3 is 18. Subtract, you get a nice remainder of 0. But there's still another 0 here. How many 3s go into that 0? 0 times. Do not miss that because our final answer should be dollars and cents. $9.60. And finally, problem number 7. This is not an adding problem. It's not multiplying. It's not even really dividing if you had your pink sheet of all those common fractions and what they equal as decimals. All you have to do here is interpret the words at least 3 1/4 ounces of ham. 3 1/4, at least 3 1/4 means that much or more. So let's start with part A's work. 3.2 ounces. Well, we know the 3 1/4 ounces from the original problem would be 3.25. Well, the easiest way to compare this is to go ahead and put a little 0 here so that way you can see 3.2 is smaller than 3.25. That's not going to be good enough because we want it to be that much or more. 3.2 is smaller. So goodbye, choice A. All right, the work for choice B. We know the 3 1/3 is 3.3 repeating if you looked it up on the page of common fractions and their decimal equivalents. Is that bigger than 3.25? Well, 3/10 is bigger than 2/10, but if you weren't convinced, you could have written another 3 because it's a repeating 3. 33/100 is bigger than 25/100. So choice B is one correct answer. There are multiple answers here. What about the work for choice C? 3 3/8 is 3.375 if you looked it up on the common fractions and their decimal equivalents page. Is 375 thousandths bigger than 25 hundredths? Well, put a 0 there. Yes, 375 thousandths is bigger than 250 thousandths. So this is another possible answer that will work, being bigger than 3 1/4 ounces. And then finally we have 3 2/9. Does this work? Well, 2/9 is 0.2 repeating. Is that bigger than 25 hundredths? If you're not sure, write down the next digit. It's not a 0, it's a 2 because the 2 repeats. Is 22 hundredths bigger than 25 hundredths? Definitely it's not. So goodbye, choice D. All right, that concludes the video on operations on rational numbers. Thank you for watching. We'll see you next time.